Hi, this is Mr. V, and today's lesson is going to be on writing algebraic expressions. For the most part, the first part of your notes is going to be a table. Do notice that I have color-coded certain parts of it, like the number of letters add, sum, more than. I've also color-coded with the property that those phrases usually go for. Now, just as a disclaimer, these phrases are, well, sentences for the most part, it's pretty easy to pick apart. However, there are tricky things in the thing known as the English language, which mess up a lot of things. So it's the problems will be on exams and on worksheets. I'll try and make sure that they're basically as clear and precise and as much like these examples as possible. However, do be ready sometimes for a little bit of a different way the words are put together. It does take some time to get used to it. So don't freak out. Basically, whenever I move it to a new spot, pause it, write down what's on there, and then listen to the audio part. Because I'm just going to read through and I'm going to go through. I'm not going to have pauses when I'm saying while we're working through this. That being said, the first operation is addition. Common word phrases would be add 5 to a number. The sum of. What's great about the word of, usually that means parentheses. And that's why I put parentheses, because whenever you see sum of, it's going to say 5 times the sum of. So you're going to take 5 times whatever the sum is first. So what that's saying is add first, so that's why it's in parentheses, because a grouping symbol would mean we're going to add first, and then multiply. So that's where some of the trick starts come in. Another thing other than of is the word than. 5 more than a number, which for addition doesn't matter, but if you notice I have 5 and a number are backwards, right? But it's still n plus 5. Whenever it says a number and it says make a word phrase, you get to choose whatever variable you want to, k, m, j, whatever. So it's up to you, it really is. Here we go, our next operation. So again, just pause whenever you need to. Would be that of the minus sign or subtraction. Subtract 11 from a number, right? The difference of a number and 11. Difference of, see, parentheses again. And then 11 less than a number, which that's why it's backwards. Okay? So that's subtraction. Moving right along. Our multiplication part right here. 3 multiplied by a number. So 3 times a number. If you notice also, I have a dot right here. However, oftentimes we'll see it without a dot. It still is there technically, but it's not there. So be flexible about it. Be ready for that. Division is another operation. 7 divided into a number, okay, is one way of saying it. Quotient of a number and 7. Quotient means like the answer when you divide. So if I was going to take a number and divide it by 7, the quotient would be whatever the answer is. So let's say, for instance, if a equaled 20, let's say a equaled 21. We had 21 over 7. Okay? The quotient would be 3. Okay? Quotient of a number and 7. The quotient of 21 and 7 is 3. So that's just an example of one way. Okay. Those are the 4 main operations you guys know of. We're going to get more into square roots when we get into chapter 4. We're going to do a lot of exponents in chapter 4. So when we get to chapter 4, we'll do another writing algebraic expressions in that chapter. And that's not going to be till the second quarter. It's actually the first part of the second quarter. Alright, so, well, I actually have 2 extra things. I put the divide 2 because you'll see like a number is cut in half. Right? And whenever you cut something in half, that's the same as you divided by 2. Half of a value. Half of a value, that's the same as if you divide by 2. So I thought that was a neat one. A good one to have. Here's another one. if I double a number, so if I double a number, that's the same as timesing by 2. If I count a number twice, I went in the store twice to get 5 bags of groceries. If I went in the store twice, 2 times 5, or 2 times the number. So 2 times a number is basically double and twice are pretty key. Sorry about that. I haven't had my coffee today. So half is a great word to keep an eye on. Double and twice. All great words to keep in mind. All right, let's do an example. Oh, bless me. Or excuse me. By the way, I'm getting my color pencils, which are right behind me. Okay. Let's talk about example number 1. We're just going to look at the first part right there, if you want to ignore that bottom part just for a minute. Example number 1. Write as an algebraic expression. So I'm going to actually depend on you to go back up to your top part. And let's go and just read. We're going to read through it first. 3 less than the product of 14 and a number. So before I write down anything, I'm looking at that, I'm going to read through it again. 3 less than, and I'm going to use the light blue because that was subtraction. The product, let's get my green out, of 14 and a number. Okay, so algebraic, now if you're noticing, hey look, there's 2 different properties right there. Yeah, there are. 3 less than the product of 14 and a number. So if you remember, I mentioned the things about less than. Well, that means that this is actually backwards. It's supposed to be, if you think about it, if I have this flipped the other way, I could rewrite this as the product of 14 and a number, or say, sorry, the difference of the product of 14 and a number and 3. There's a lot of different ways of writing these. So if I've got this backwards, I'm going to have my subtraction, well, 3 less. Okay, so it's going to be 3 less. I'm taking 3 away. The product of 14 and a number. So I've got 14 times some number. Let's choose x. Okay? So one way of writing this, and I know I wrote those pretty spaced apart, is 14x minus 13, or minus 3. I could also write this without the dot. 14x minus 3 would also be fine. But because it's 3 less than, I wrote that first. Minus 3, and the product stuff is going to be in the front. Because the product is 14 and a happening. 3 is being taken away from that. So, okay, so that's the first one. Let's look at this next part. -6 divided into the difference of 28 and a number. And let's see. Difference again, that was subtraction. What else we got? Divided. Okay, that's the purple one that I used. Right? So -6 divided into the difference of 28 and a number. Okay, so if I look back up here at my examples, if you notice 7 divided into, that means -6 is going to be on the bottom. So I'm just going to put -6 right there, and -6 is dividing something. -6 is in the denominator. Well, -6 divided into the difference, so it actually means the subtraction is going to happen up top. The difference of 28 and a number. If you remember looking back up here, the difference of, so if I put difference of 28 and a number, then I've got to put 28 first, and then a number after that. So we're going to have 28 minus a number. Let's go with m. So this is, remember my order of operations, this is a fancy fraction. So I'm going to take -6, I'm going to divide it in 2. the difference of 28 and a number. So again, it takes some practice. That's what we're doing tomorrow. But those are two examples right there. Let's do two more examples. Let's do another example over here. Okay. Now we're going to write a sentence. And there's more than one way of writing a sentence, however you want to write it. This part, you've definitely got some creative ingenuity that you can come up with. So, let's see. We're going to write a sentence for each expression. So, for me, think about how you read it, like read it out loud. For me, this is 6 minus 4x is how I would normally read it. So if that's the case, I'm gonna look at my phrases over here, and I've got 6 minus 4n. I'm gonna say, for me, this is the difference because I see subtraction of. The difference of means that I'm gonna put it in the exact order. I have 6 and, well, it's not just 4. It's 4 times x, which product is a great word. So difference of 6 and the product. So now I'm just looking at this part. Right? The product of 4 and, now you don't say x, right? You say a number. Period. Done. And that's it. Difference of 6 and the product of 4 and a number. Okay? Next one. 38 times 17 plus x. Okay. But if you think about what the order is, what has to happen first? The 17 plus k. And I mentioned earlier that whenever we see the parentheses and there's adding going on, that was sum of a number. And that's backwards for you, so that's not helping. So that's going to be the sum of, means parentheses. Is going to have addition with parentheses over it. So this is I can say 38 multiplied, and it's not just by 17, and it's not just by k, it is multiplied by the sum of 17 and, not k, a number. Okay, that's it. 38 multiplied by the sum of 17 and a number. Those are two examples. Now let's now I've got a word problem down here. Start third example. Pause the video and write that down. Okay, good. Okay, number 3. I'm going to read it out loud. Einstein has 5 lemon trees that always produce the same number of lemons. By the way, that produce should have is a C, not an S. That produce means make. The same number of lemons every year. Einstein borrowed 54 lemons that he needed for a bake sale from like a friend. After his trees have been picked and he has repaid his debt, how many lemons will he have? Write an expression of this. So the first thing I'm going to do is I'm going to write L. You got to, first off, think about what you don't know. Do you know how many lemons his trees are going to make that year? I don't know. So we're going to say L. say this is the number, or let's say the amount of lemons one tree produces. Okay, so that's L. L is only one tree and how many it makes. So if there's 5 lemon trees, one way of doing it would be to take L plus, but you know not to do that. You should be doing 5 times L. Okay. Now, so that's from the 5 lemon trees. And it says he repaid his debt. He repaid his debt. So think about how many he borrowed. Borrowed 54 lemons. So if he borrowed 54 lemons and he repaid that, did he get more back or did he lose some? If he repaid it, he would lose some. So it should be minus 54. So this would be the number of lemons he has left after he's repaid his debt. Okay? So, there you go. That's algebraic expressions, and I'll see you guys tomorrow.